Hey guys, this lesson is approximate binomial distribution. So here's our board problem for our class, you guys. So I'm going to give you, you're going to have to pause it right here, you guys, and then write that down. And I'd pause it right after this slide right there. There's the answers right there that I'll go over in class. We're just plugging in the numbers here. So here we're plugging in 25 for n and 0.35 right there. And so this is going to be 0.65 because it's 1 minus that. Okay, so here we plug in. Whoops, I forgot a number right there. We'll have to figure out what that number is when I get back to class. I'm out in my truck right now. My student teacher is teaching, so I'm just out in my truck putting this on here. Okay, and then there's the answers right there. And we'll explain that when we get into class. Okay, so remember in chapter 10, you guys, and this is 10.6, I think. Excuse me, in a binomial distribution, there were n independent trials. Each trial had only, because it was binomial, it only had two possible outcomes, either success or failure, which meant on or off, left or right, male, female, etc. There's only two choices right there. And the probability of successes is the same in each trial. So if it equals p, then the probability of failure would be 1 minus p. Do you remember this? Kind of ring a bell, you guys? And for the binomial experiment, the probability of exactly k successes in n trials was given by this formula right here. The probability of k successes would be nck, which is n combination k, p to the k, and then 1 minus p to the n minus k power. Okay, and we did some examples in lesson 10.6. Okay, so we're going to use that, refer to that in just a second here. So to approximate binomial distributions and test hypotheses right here, I don't think we're doing this part right here. We're just doing approximate binomial distributions in this lesson here. So normal approximations of binomial distributions. Okay, so consider the binomial distribution consisting of n trials with the probability of p successes. Okay, so it's binomial, so we just reviewed that right now. So as long as n times p is greater than or equal to 5, so whatever your size is times your probability, if it's greater than or equal to 5 and n times the complement of the probability is also greater than or equal to 5, then the binomial distribution can be applied by a normal distribution with the following mean and standard deviation. Okay, so your mean is going to be n times p, and your standard deviation is going to be that np times 1 minus p. Okay, and the square root of all of that right there. Okay, so let's apply that right here. Okay, so this is example 1 on page 763. If you're in my class, you just have to write this part down, the purple stuff you don't. So according to a survey conducted by the Harris Poll, 24% of adults in the U.S. say that their favorite leisure time activity is reading. So you're conducting a random survey of 250 adults. Okay, so there's N right there. What's the probability that you will find at most 53 adults who say that reading is their favorite leisure time activity? Okay, so here we go. So this is a binomial distribution. All right, where the n is 250 and the p is 24.24, 24% right there. And at most means we're looking for less than, remember, I'm at most 53, so I'm at 53 or under. I'm 52. So what's the we're looking for the probability that x is less than or equal to 53. Okay, well now, the binomial distribution, or the binomial probability formula, is given this right here. So the probability that x is less than or equal to 53 would be each probability, x equals 0 plus x equal 1 plus the probability that x equals 2 all the way up to the probability of x equals 3. Okay, get out your calculators and go. I'm just kidding, you guys. That would take you too long. So we're prone to make mistakes, and it just takes too long. So instead, we can approximate our answer using a normal distribution with a mean and standard deviation using our information that we gave in section A. Okay, so in section A, our mean was n times p, and our standard deviation was np times 1 minus p and the square root of all that. But np has to be greater than 5, and n times 1 minus p also has to be greater than 5. So let's check, you guys, okay? So if we plug them in right here, so remember, n is 250 and p is 24% right there. So let's just plug them in right there, okay? So they both are greater than 5, so they check off. So we can go ahead and use our approximation right here. Okay, so our mean is 60, okay, and our standard deviation is approximately 7 when we crank that out right there. Now let's answer this question right here. Okay, so recall we're looking for the probability that x is less than or equal to 53. Okay, well, if our mean is 60 and what's less than or equal to 53, remember from a couple of lessons ago, our standard normal curve is this, you guys. 53 is approximately 7 less than 60. It's approximately 1 standard deviation away from the 60 right there. So with our mean of 60 and standard deviation of 7, 53 is about 1 standard deviation below the mean, which means to the left of the mean. Okay, so remember we have this groovy standard normal curve. There's our mean right there. There's our 1 standard deviation, 2 standard deviations, 3 standard deviations. We want to know less than or equal to 50. So we want these 3 areas. Do you remember these percentages? This is what, 13.5%? This is 2.35, and what's this? 0.15%. Do you remember that, you guys? So if we add all those up, then it's going to be about 0.16 or 1600ths right there. Okay, so the probability that at most 53 of the people say that reading is their favorite leisure time activity is about 0.16 or 16% right there. Okay, all right, that would be what you're doing in this lesson, and if you're in my class, that would be your homework assignment. Take care.